Thank you. Hello, everyone. My name is Taha Kalim, and I'm an AWS solution architect specializing in VMware Cloud on AWS. In this episode, we will see how you can simplify and accelerate your cloud journey by migrating your on-premises VMware workloads to the cloud using VMware Cloud on AWS. There are three key learning objectives for this session. The first one is we're going to go through the available migration options for VMware Cloud on AWS. And then we're going to take a look at how you can set up your environment for hybrid migration with vMotion, followed by going through the setup for VMware Hybrid Cloud Extension, or ATX, for hybrid migration. I would like to mention here that on certain slides, I have placed QR codes that link to relevant documentation. You can scan those using your phone to view the documentation. Let's first start by taking a look at the different tools and strategies available for hybrid migration. The first option that you have is using the long-distance vMotion feature available with VMware Cloud on AWS. You can link your on-premises environment and VMware Cloud on AWS using VMware Hybrid Linked Mode, which allows you to manage your on-premises and cloud vCenter servers from a single pane. The process to enable and disable the linking is very simple. And you can maintain separate permissions between the Cloud SDDC and the on-premises vSphere environment, all using the vCenter console. To use live vMotion, then you can simply stretch your layer 2 networks using the L2 VPN feature of VMware Cloud on AWS and initiate live vMotion from the vCenter interface, just like you would when migrating between two on-premises environments. With this approach, it is important to keep in mind that the usual restrictions that apply to vMotion also apply here. These include things such as EVC, compatibility of vSphere versions, and of course, latency between the on-premises and cloud environment. The second more robust and scalable migration tool is VMware Hybrid Cloud Extension, or ATX. It is included with the subscription for VMware Cloud on AWS and has wide interoperability across vSphere versions and on-premises networking and storage technologies. It allows you to create migration groups and do large bulk migration of virtual machines. And there is also built-in WAN optimization, which provides deloop and compression, allowing you to use as little as 100 megabits per second internet connection to migrate virtual machines. You're also able to stretch your on-premises network using the ATX network extension feature, so that you can migrate your virtual machines completely online. It is simple to access via the vCenter plugin. There's also a standalone web interface, and you can automate it using the API and Power CLI as well. The subscription includes the ATX Enterprise features that allow you to choose from several migration types, including cold migration, which allows you to migrate VMs while they're powered off, vMotion to migrate VMs completely online without linking your vCenter servers, bulk migration that allow you to replicate VMs in the background and then automatically switch over at a pre-scheduled time, like a change window or a weekend, with a simple VM shutdown on premises and then power on in the SDDC. And then we also have replication-assisted vMotion, which is similar to bulk migration, but instead of a reboot at the rescheduled time, it uses vMotion to switch over live to the VM running in the SDDC. Most recently, the OS assisted migration option was also added. Finally, the last option is to use backup and restore tools. Most popular data protection software are supported with VMware Cloud on AWS, and VMware publishes the latest compatibility in their compatibility matrix site for you to understand whether your tools that you have are compatible to migrate using backup and restore. Now, how do you select a migration method? You need to understand the business requirements and interdependencies for all the applications that you're migrating. You should be able to answer questions like, is it a one-way migration, or do I need portability between the on-premises and the cloud? What are the availability requirements for the application that you're migrating? Are there multiple virtual machines that form the application that must be migrated together? Then you also need to take into account the compatibility of the two environments. So we need to take into account everything from EVC, the CPU models, to virtual machine hardware versions, and even the type of virtual networking in use in the on-premises environment. Finally, you should also evaluate what kind of connectivity you have between your on-premises data center and the cloud. Will you be using the internet? Will you be provisioning direct connect for your connectivity to the SDDC? These are all decisions that you need to, or all factors that you need to take into account when making your decision on the migration method. As we evaluate applications, we can place them into workload migration buckets. For virtual machines that can be migrated offline, such as test virtual machines, for example, you can use cold vMotion, backup and restore, or even HCX cold migration. Applications that are running such as staging environments or development, or those that may be sensitive to stunning, can take the minimal downtime path using HCX bulk migration. Finally, the need to migrate without downtime can be addressed using live vMotion, HCX vMotion, and HCX replication assisted vMotion. So let's now take a look at hybrid migration using vMotion. This requires us to set up hybrid link mode first for online vMotion, and then we need to stretch a layer 2 network between our on-premises environment and the VMware Cloud and AWS environment. Now, there's two options that you can use. Let's first look at the internet option. So when connecting over the internet, you should first establish a route-based or policy-based IPsec VPN from the on-premises environment to VMware Cloud and AWS. Then you can deploy a cloud gateway appliance in the on-premises environment, which uses the IPsec connection for communication to the Cloud vCenter server. And once your two vCenter environments are linked using a hybrid linked mode and the Cloud Gateway appliance, you can create a L2 VPN for stretching layer 2 networks from your on-premises environment to the cloud. Now, if you have an NSXT environment on premises, you can use that, or you can download the free NSXT standalone appliance. An extended network segment is automatically created in the SDDC, and VMs on the segment can seamlessly communicate with on-premises VMs and route over the L2 VPN. Both the L2 VPN IPsec connections use the public IP address that is configured in your SDDC. When you're using Direct Connect, the communication between the Cloud Gateway appliance and the SDDC vCenter traverses the Direct Connect connection. Now, Direct Connect is a physical connection between your on-premises environment and VMware Cloud and AWS, and you can then create an IPsec connection if you want to, but it's not required. The L2 VPN connection is also established directly over the Direct Connect connection, and it uses the private IP of the NSXT edge in the SDDC. Now, time for a demo.
How we can set up hybrid link mode and a layer 2 VPN to do a vMotion from our on-premises environment to VMware Cloud on AWS. First, we need to get prepared for the vMotion using hybrid link mode. The most important thing is establishing connectivity between the on-premises environment and the VMware Cloud and AWS SDDC. Then we need to make sure that the SDDC is configured for vCenter to resolve to the private IP, and we need to make sure that we have synchronized the time in our on-premises environment with an authoritative time source using an NTP server. We also need to make sure that we have an AD group that will be used to give cloud administrator permissions to a set of users when we deploy the hybrid linked mode Cloud Gateway appliance. And we have to make sure that we have all the prerequisites ready for the on-premises Cloud Gateway appliance. This includes the IP addresses, the DNS entries, and all the information that we need to deploy and configure the Cloud Gateway appliance. Finally, we also need to make sure that we have all of the firewall ports configured to allow communication between that on-premises vCenter environment and the cloud gateway appliance that we'll be deploying. And also for the L2 network extension, we have to make sure that we are able to deploy the NSXT standalone edge appliance, and we have all the prerequisites required for that in place. The first thing we need to do is log into the VMware Cloud Services console. I'm going to use my credentials here and sign in. And once I'm signed in, I will be able to see all of the cloud services that are provisioned for my account. I'm going to go and choose the VMware Cloud and AWS service, and I will be able to see all of the SDDCs that have been deployed in my account. We'll be using the demo SDDC 1 for our demo today. And if you go to the network and security tab here, we can see that the on-premises environment is connected to the VMware SDDC through a direct connect private virtual interface. Next, I'm going to make sure that I have the right firewall rules configured. So in this, I'm going to go to the management gateway under the gateway firewall. And you can see here that I have my on-premises management network configured as a source for HTTPS, ICMP, and SSO traffic to my Cloud vCenter server. Also, the vCenter server in the SDDC is allowed to communicate to any destination, which basically allows all traffic to the internet and any other IP address as well. Under settings, I have made sure that the vCenter address can be resolved over the private IP. It can be edited here, and once you're done, you can hit save. I've already put that in place, so my IP is getting resolved to the private IP. Now, in order to get started with the Cloud Gateway appliance, I need to download the vCenter Cloud Gateway, which is available under the Tools section of the VMware Cloud console. I'll click on Download here. This will open and automatically log in to my VMware account that I'm using to log into the Cloud console. Clicking the download button again actually opens the right address where I can download the Cloud Gateway appliance. I will download this first item here, which is the VMware VCGW ISO file. And once I have downloaded this file, I can go ahead and deploy it in my on-premises environment. In my case, I've already downloaded actually this appliance ISO file. I'm going to mount it here, and if Windows automatically mounts it, I'm going to go into the UI installer and run the installer to get started with the deployment for the Cloud Gateway appliance. I'm going to click on Get Started here to start the deployment, accept the license agreement, and you can see some of the details are already filled out here because I have run this installer once before. But basically, we are entering the vCenter address, the credentials for the administrator account for the vCenter server. So I'm going to put in my credential here from my on-premises vCenter. All right, I'm going to click on Next, then accept the certificate warning. I'll select the folder I want to deploy and the resource cluster that I want to deploy my appliance into. The VM name is the same I'm using for the DNS entry that I've put into place for my environment. I'll put the root password, click Next, select the storage, and click Next. Here you can see that I'm going to select a network, which is the management network. The IP address, the FQDN information are showing up from my previous execution, but basically, let me just remove the extra DNS server here. So I'm just keeping the on-premises DNS server. I have the gateway configured, the subnet mask, and the IP address, and the FQDN. I'm going to click Next. Make sure that the NTP server is configured. It's the same for me as my DNS server, and this will kick off the deployment for the vCenter Cloud Gateway. Once the deployment is finished, I'm going to click on Launch and go in and get started with the deployment wizard.
Here we click on get started, and we're going to say that yes, we meet all of these prerequisites for my on-premises environment. Once I've made sure that these prerequisites are in place, I'm going to click configure, and here you must enter the same root credentials that you had configured when you were deploying the appliance. Enter the credentials, log in, and then you can get started with the rest of the configuration. So first, I need to enter the vCenter's address, the username, which is cloudadmin@vmc.local for all SDDCs. I'll copy the password here for my SDDC from the SDDC console. Click next, connect to accept the certificate warning. And here, since I'm using an embedded platform services controller, you can enter whatever your platform services controller is and enter the credentials for the administrator, SSO administrator credentials. Click on connect, and that will get your Cloud Gateway appliance added to the SSO domain for your on-premises vCenter server. This will take around 5 minutes to complete, and then we will continue once that is done. Now that it's done, I can go ahead and configure the Active Directory for my environment and join the Cloud Gateway appliance to the Active Directory. I'll click on next after entering the details. And here now I can select the Active Directory group that I want to give the management or cloud administrator privileges. So I'll select vCenter admins from my domain environment. This can be something that is more relevant to you and your environment. Once done, I'll click on restart, and that will finish the configuration for hybrid linked mode between my on-premises environment and the VMware Cloud and AWS environment. So then I can manage both the environments from a single console. Once I'm done, I can simply go ahead and use the FQDN, since I have already configured it in my DNS, and log in to the console. It will prompt me for the username and password. I'll use a user that is part of the AD group that I had selected when I in the last step. Click on login, and this should now display to me both the on-premises environment and the VMware Cloud and AWS in a single console. Okay, so here I can see that's my on-premises vCenter, and that's the SDDC vCenter server, and I can see both of those environments, and I can see the hosts, the clusters, and all those details, and manage both environments in a single pane. Now that hybrid link mode is configured, you need to go and configure the layer 2 VPN for your environment so that you can start with vMotion completely online. So for that, I'm going to go into Network and Security tab, and in the VPN, go to Layer 2 VPN and click on Add a VPN tunnel. You should have already allocated an IP address that will be able to communicate with the private IP here for your environment or direct connect. I'll enter my IP that I will use and click on Save. And I will get a pop-up here that will give me the link to download the NSX Edge standalone appliance to deploy on my on-premises environment. Here we will download the NSX Edge for VMware ESXi, and you can click on download now to get started. I have already downloaded this, so I can go ahead and get started with the deployment in my on-premises environments. I'm going to use the Cloud Gateway to do it, since I can manage both environments here. So I'm going to put in the select the resource cluster here and click deploy OVF template, select the Edge appliance file that I had downloaded, NSX Edge 3.1, yeah, and then click on open to get started. Click next. Here you should enter the virtual machine name that you want. In my case, I'm using the same VM name as the DNS entry I made. Click on next. Select the resource cluster that you want to deploy your virtual machine in, and review these details. We're going to deploy a medium appliance for the L2 VPN. I'm going to click on next here, select the data store next. Now, this is one of the key things that we need to keep in mind. Here, we have to understand what these network adapters are. Network 0 is for management, which you will use to access the management interface. Network 1 is the uplink port group, which will be able to access the private IP that you have in your SDDC, which is used for the L2 VPN connection. And the third network adapter is where you will have all of the trunked VLANs that you want to extend from your on-premises environment to the cloud. The last one is optional and used for high availability when you need to have more than one appliance deployed, and so that you can have an appliance fail and the second one automatically take over for all your communication to not be interrupted between the two environments. So I have selected all of those details here, and I'm going to click next. I've entered the root password, the admin password, and audit password for my appliance, using the same default admin and audit usernames. And then next I need to actually enter the make sure this is the autonomous edge which you are deploying. That's an important thing to select. We're going to put in the host name here and enter the IP address, the management IP address, which is the first port group that we had selected. So I'm going to put in the management IP that I want to use, the subnet mask, and then the gateway for that subnet, 10.31. I'll put the DNS information for my on-premise environment. My NTP server is also the same as my DNS server. I'm going to click on enable SSH. You can leave that if you don't need it. Also root SSH. If you don't want it, you can leave that unenabled. I'm just enabling it for this environment. And then we have to define the external port. Now, this is the port that will be able to communicate to the remote IP, which is in the SDDC. So that is the second Ethernet interface adapter. And I don't want any tagging. So I'm going to say VLAN 0, Ethernet adapter 1, which is the second Ethernet adapter. Then I'm going to put an IP address for the uplink port group that will be able to communicate with that VPN, L2 VPN private IP of the SDDC. So 172.20.10.59, and the subnet mask is /24. I'm going to put the gateway here. Don't need to define the internal port here. That's the management port. You don't need to define that. And that's pretty much it. We don't need to configure HA. So if you want to configure HA, you can actually go ahead and add all the details. And you would also configure the primary node IP if you had already deployed it and you were deploying your secondary node. We can leave all the other settings and go ahead and click next. And then click finish to deploy. Once the appliance has successfully deployed, we can go ahead and power it on. So right click, power on virtual machine, and then we'll wait for the virtual machine to power on and the DNS name and IP address information to show here for us to continue with the configuration. Okay, we can see that the IP address is there, and we can open the console and see that the virtual machine is online. We will then navigate to the IP address we had selected at the time of deployment and log in using the admin credentials that we had configured at the time that we were deploying the appliance. So I'm going to paste the password here, click login, and I can go to the port tab here. We can see that the management IP shows up here, and then under the L2 VPN, right now there is no L2 VPN sessions that have been configured. Click on add session to get started with the configuration. Say SDDC L2 VPN. Enter the local IP, which is the uplink IP, so 172.20.10.59. In my case, make sure you enter the correct IP for your environment. I'll copy the local gateway IP for the SDDC, which is 10.7.101.141 in my case. I'll download the config here. So make sure you download the config. This has the pre-shared key that we need to use to put into our configuration for the L2 VPN session. So I'm going to paste that key here and hit save.
Now we can see that the session is enabled, but it's still down, not fully established. Here we can go and refresh, and we'll see soon that this status will change to up. So here you can see that the status is up, and if you refresh here, we'll also see that the VPN is online. Okay, so now in the on-premises environment, I am going to go ahead and add a port, put the name, put the VLAN ID that for the VLAN I want to extend, and I'll select ETH2, which, remember, when we were deploying the appliance, we connected to the trunk port group. Now that port group is trunking 631, and so I can extend it. I'm going to go into L2VPN session and add the port and give it a tunnel ID. I've used the same ID as the VLAN just for the ease of management. So my VLAN ID and my tunnel ID are the same. It doesn't matter as long as I use the same tunnel ID on the SDDC. So here I'm going to click and add segment and enter the segment name quickly and put the tunnel ID 631. Again, the tunnel ID here, 631, is the same as the one that we just configured. So click save. And now if we go into the segments, we will see a segment added here. The type for that segment is extended, which means now that VLAN 631 has been extended from our on-premises environment into the VMware Cloud and AWS SDDC. With the layer 2 extension now configured, we're ready to do vMotion. And here you can see everything is healthy. Both the status are showing success. But one thing we have to make sure that we do first is make sure that gateway firewall is, the management gateway firewall is allowing inbound ESXi vMotion traffic. So from on-premises ESXi hosts to the, we allow VMware vMotion and ping to the ESXi host in our SDDC. And once that firewall rule is in place, we can actually go ahead and do the vMotion. So here I have two VMs, VM1 and VM2. 10.3.30.7 is VM1 and 10.3.30.8 is VM2. I'm going to open a console into the second VM here and start a continuous ping to the first VM. So ping 10.3.30.7, and once this ping has started, I will go ahead to the VM1 here and simply right click it and kick off the vMotion by going and clicking on migrate. Select change both compute resource and storage. Now this is again like any other standard vMotion. I'm selecting the destination host or resource pool and selecting the destination storage. You select your folder that you want to put the virtual machine in. Make sure you're selecting the extended network on the destination side. It's automatically selected here because, again, the names are the same. Click next and click finish. This kicks off the vMotion. One of the key things to keep in mind here is look at the latency. Right now, the latency is well under 1 millisecond. Once the virtual machine is running in the SDDC, this should go up. If I go here, I can see actually the progress, and I'll see two progress bars because one is for the cloud SDDC and one is actually for the on-premises vCenter. And here we see that the ping has transitioned. There were a few packet drops, but that is expected. Now we have moved a virtual machine from our on-premises environment completely online to VMware Cloud and AWS. Perfect. So that was a recorded demo, just so that we could fit it into the time that we have. But you can always refer back to it once this session is available for you to watch on demand. Now, let's look at the second approach, which is about migrating using the HCX or hybrid cloud extension. So the way HCX works is it creates a service mesh that interconnects the on-premises and cloud environments. The HCX Cloud Manager is deployed at the click of a button, and all required configuration in the cloud is automatically done. Once the HCX Cloud Manager is deployed,
we then download the ACX connector virtual appliance and deploy it in the on-premises, connecting it with the on-premises vCenter server. The two sites are then paired over the internet or direct connect. So again, here you can choose to do this over the internet or using direct connect. We then create the compute and network profiles that define the networking and compute resources that will be part of the service mesh. Finally, the service mesh is then created, which deploys the ACX appliances, including the interconnect appliance that connects the on-premises and cloud networks, including management, vMotion, and replication. The interconnect appliance is what enables the VM migrations, and so this appliance is always deployed. Then there are two more appliances. So the WAN optimization appliance, if that is selected, if the WAN optimization feature is selected, the WAN optimization gets deployed in the service mesh. And lastly, one more appliance gets deployed. Now, it could be one or more network extension appliances that get deployed, and each one is able to extend up to 8 layer 2 networks from your on-premises environment to the cloud environment. So let's look at network profiles and compute profiles, which are really integral to configuring your service mesh. Network profiles define how various components of ACX communicate over the network. In VMware Cloud and AWS, the network profiles are automatically created. So again, it's when you go ahead and you click that deploy ACX button in your cloud console, all of this is automatically done for you. Some modifications may be needed, especially when you're trying to use direct connect and not going over the public internet for your ACX communication. In on-premises environments, the network profiles all need to be configured manually. We'll take a look at how to do all of those. Now, there are 4 traffic types that we need to create the network profiles for. You can use the same profile for all traffic types, or you can create a separate profile for each of these traffic types. It all depends on your network configuration. The uplink network profile defines the port group and IP pool that will be used by ACX to connect to the remote ACX appliance. So we're talking about the ACX appliances that are deployed in the on-premises environment and the cloud environment. They will communicate over the uplink network. Then we have the management network profile that defines the port group and IP pool that will be used by the ACX appliances to communicate with local ESXi and vCenter servers. And then we have the vMotion profile that defines the port group and IP pool used by ACX appliances to communicate with the ESXi vMotion VM kernel adapter. So if you're using the same VM kernel adapter for vMotion management, which you shouldn't be, but if you are, you don't need to create a separate vMotion profile. But most production environments usually have a separate vMotion VM kernel adapter, so you'll create a separate vMotion profile. Lastly, the replication network profile defines the port group and IP pool used by ACX appliances to communicate with the ESXi replication VM kernel adapters. If, for example, the management network can handle all of the traffic above, then it is sufficient to just create one profile and use it for all the traffic types when configuring the compute profile. So what is the compute profile now? So the compute profile defines all of the parameters for the service mesh deployment. This includes the services that will be enabled. So whether we want to enable a WAN optimization, whether we want to do network extension, then we select the services cluster where the workload that needs to be migrated resides. Then we have to select the deployment cluster where the ACX services appliance will be deployed. So the WAN optimization appliance, the network extension appliance, the interconnect appliance, all of those get deployed into the deployment cluster. Then we have the selection for all of the network profiles. So the management, uplink, vMotion, and replication network profiles need to be selected in the compute profile. When it comes to connectivity, as I said, you can do it over the internet or direct connect. When we're doing it over the internet, the traffic for the vCenter or the communication between the workloads and the two sites needs to go over the IPsec VPN that you deploy. So you have to create an IPsec VPN for all workloads between your on-premises site and the SDDC to communicate with each other. The HCX appliances themselves don't use any IPsec VPN that you may have already deployed. So they actually connect directly over the internet using the public IP. So your SDDC HCX appliance has a public IP, and your on-premises HCX appliances connect to that public IP for those appliances. And in the SDDC side, these public IPs are automatically deployed and configured in the network profile. The HCX, and again, you don't need public IP. So your on-premises site can be completely private. It does not need public IPs. It will initiate the connection to the public IP for the SDDC. So the HCX interconnect appliance at the source site initiates a secure tunnel to the public uplink IP for the interconnect appliances. And similarly, the network extension appliance at the source site creates a separate tunnel to the public IP for the network extension appliance in the SDDC, over which the L2 networks are stretched. Now, when we're doing this over Direct Connect, DX is used for all communications between the workloads, so no need for an IPsec VPN or anything. And the HCX appliances communicate using the private uplink IPs over Direct Connect. So there's no need for a public IP in the SDDC. There's no need for a public IP in the on-premises environment. All communication happens over private IPs. You must configure a private IP pool manually because in the network profile that is automatically created when you deploy HCX in the cloud, there is no direct connect pool IP defined. It's all working with public IPs and internet IPs. So you go ahead and you configure the direct connect network profile with the private IP pool that you want to use, and then when you deploy the HCX interconnect appliance at the source site, it initiates a secure tunnel to the private uplink IP for the interconnect appliance in the SDDC. And similarly, the network extension appliance at the source site creates a separate secure tunnel to the private IP. So one is the interconnect connection that happens, and second one is the network extension. If you're using network extension, that is a separate secure tunnel that gets deployed. Okay, so now time for a demo to see how this is set up.
Look at how we can set up HCX between our on-premise environment and VMware Cloud on AWS. First, we have to make sure that we go through all of the preparation steps, including verifying the resources are available in the on-premises environment to deploy the HCX appliances, validating the software version requirements align with the on-premises environment that you have and the feature set that you're looking for, ensure that the network connectivity and firewall rules are in place, and also make sure that the requirements that you have meet the service limits and the configuration maximums for VMware HCX. You can scan the QR code on the right-hand side to access the documentation. Let's now look at how we can deploy the HCX manager in VMware Cloud and AWS. If we go to our add-on tabs, we will see that VMware HCX is already active as an add-on. This is by default for all new SDDCs that are deployed in VMware Cloud and AWS. We can then go into the HCX Cloud console by clicking on the Open HCX link there, and there will be an option to deploy HCX for our SDDC. We'll select the SDDC and we will click on deploy, at which point we will kick off the deployment within our SDDC. This will take about 20 minutes to go through. Okay, the deployment is now finished, and that we can see that the Open HCX link is available to us, or we can undeploy HCX if needed. I'm going to click on Open HCX, and this should launch the HCX console for me. But in this case, the network firewall ports are not open, so I do need to go into the network and security tabs within my SDDC and create the firewall rules to allow access to the deployed HCX manager. I'll create a new gateway firewall rule in the management gateway for incoming traffic from my on-premises environment into the VMware Cloud and AWS SDDC. ATX Manager. So in the sources, I'll select my on-premises networks group that I created earlier. So that's my on-premises management. And then in the destination, I'll select the ATX Manager. This is a system-defined group that is automatically created at the time of ATX deployment. In the services, I'll select all four, including HTTPS, Appliance Management, SSH, and ICMP, and then click on Publish. This should now allow me to access the ATX Manager. I'll refresh, and I will get the login prompt. In the login prompt, I have to enter the vCenter credentials from the SDDC. Click on Open vCenter, Show Credentials, and copy the password here. Enter the default username for the SDDC, which is cloud.admin@vmc.local. Paste the password, and then log in. Now we can download the on-premises HCX connector appliance from the system's update page in the Cloud HCX Manager console. The request download link button becomes available shortly after you load the page. Click on the request download link, click copy link here, and I'm going to go into my jump station and start the download. But since I already have it, I'm going to start the deployment process, and I'm actually going to use the Cloud Gateway appliance where I can see both vCenter servers. So in my on-premises vCenter in the resource cluster, I'm going to click on Deploy OVF Template, select the file that I have just downloaded, and click Next. Put the ATX virtual machine connector virtual machine name, so it's ATX-connector. Click Next, and select the resource cluster 2 for compute. Review the details and click Next for the ATX appliance. I will have to select I accept the license agreement. Click Next. Select the storage and select the management network for the ATX manager, and then enter the details. Okay, I'll put the admin user password, the root password, the host name will be the same as virtual machine, ATX-connector, management network IP from my 172.20.10.58 network, and then the /24 subnet, the gateway. I've also created a FQDN for my host name here so that I can refer to it by the DNS name in my configuration. I could enter some static routes if needed, but since my default gateway has access to all my networks, I do not need to define any static routes to be used by the ATX manager. I will put the DNS server and the domain name here for my environment. My DNS server is an NTP server the same. Click Next, and then click Finish to start the deployment for my ATX connector in my on-premises environment. You can monitor the progress for the deployment in the recent tasks section, and once the ATX appliance is deployed, you can go ahead and power it on and wait for it to show the IP address and DNS name in the vCenter console. Once the connector is deployed, we can see that the IP address and DNS names show here, and we can then simply go to the console and go into the administrator console on port 9443 to continue the configuration for the ATX connector. We will log in using credentials that we entered at the time of the appliance deployment, and then we will be taken through a guided wizard to configure the ATX appliance. The first thing that we need to do is get the activation key to enter into our appliance. Remember, your appliance needs to be able to access the ATX activation server at this address. To use here, we're going to go into the ATX Cloud console, go into activation keys, and create an activation key to use with our appliance. Click Confirm. That will give us the activation key. We'll copy that key and enter it into the console. Click Activate, and this will start the activation process. Next, we need to enter an address. So I'm just going to enter Washington, D.C. here. Click Next. That's the system name that I want to choose. I want to just include here that this is my site 1 as an example. Click next, and that's it. The ACX is activated. I can proceed with the next steps. Okay, I'm going to enter my vCenter server credential and address. So vCenter 2.aws.vmc lab. I'm going to enter the administrator credentials for the environment and then put in the password. If you have an NSX environment, you can link your NSX manager optionally. There's no NSX in this environment, so I'm going to click continue. If you have a separate PSC, you can enter the address for your PSC, or if you have an embedded environment, you will enter the if you have an embedded PSC environment, you will enter the vCenter address here as well. So I will enter the vCenter address for the PSC for single sign-on as well and click continue. That's it. The ACX system is configured. And now I can click on restart, which will restart the appliance, and I will be able to then start the process of connecting it to my cloud environment. Once the appliance restarts, we can see that the vCenter is linked and online, and we can also see the SSO environment that is linked. Now we can proceed to the actual ACX console. We remove the port 9443 and access the HTTPS port, at which point we enter our username and password from the vCenter SSO and click login. Once logged in, we can go into site pairing and click on connect to remote site, enter the remote site HCX URL, which can be found in the settings page. And also it's important to keep in mind that the FQDN for HCX should resolve to the private address, just like the vCenter server, so that when you're connecting to it, you're connecting it over a private connection. And if you recall, in our SDDC, we're using direct connect between our on-premises environment and VMware Cloud and AWS. Then I'll enter the cloud admin credential, which I can always get from the vCenter server here. Click on paste, and that will connect my HCX connector to the VMware Cloud on AWS HCX manager, creating a site pairing between the two environments. Okay, we can see that the pairing has been established from my on-premises environment. This is the system name that we had entered at the time of deployment to VMware Cloud and AWS. And we can now actually proceed with creating a service mesh between our on-premises environment and VMware Cloud and AWS. At this point, we have the ACX Cloud Manager deployed, we have the ACX connector deployed on premises, and the two are connected to each other. And we can now proceed with creating the ACX service mesh. So we'll go into interconnect, and this is where we can start the process. Now remember, the first thing that we have to do is configure the compute profiles and the network profiles that we talked about. So in our on-premises environment, right now, we do not have a compute profile or a network profile. So first thing we're going to configure is a network profile. Click on the Create Network Profile button, and we're going to get a prompt with the details to fill out. And the first detail we need to select is whether we're going to use a distributed port group, a standard network switch, or an NSX logical switch. We're using distributed switches here. I'm going to select the management port group, and I'm using management port group because that is the port group that has the IPs which can access the remote HCX environment. I will also use the same port to communicate with management addresses, i.e. the vCenter and the management for ESXi. In addition to that, I'm also using that same network for vSphere replication. So all three of those network traffic types for HCX will go over this port group. So I will select all three of them. You can plan out all of this upfront for your environment and select and create the requisite network profiles. Now keep in mind that you don't need to create a single network profile for all types of traffic. And in my case, I'm actually going to create a separate one for vMotion. The other thing is when you're selecting the number of IP addresses to use, you can use this calculator here by selecting what traffic types you want to pass and number of service mesh you will be deploying, number of network containers that will be participating in the network extension service, and the number of network extension devices that you will be using. All of those combined together will define the number of IPs that you need to include in the IP pool. In my case, I need 5, but I'm actually going to put in 10 into my environment. So 10 .221 till 172.20, 10.230. My subnet prefix is 24, my gateway is 10.1, and my DNS server, primary DNS server, is all included here. I'll click on create, and that will go ahead and create my first network profile. Then I'm going to create the second one and call it vMotion. And I will select the vMotion port group to use here. I will use the vMotion subnet range, so 20.11.221 to 172.20.230, port group 24, prefix length is 24, and the gateway address is 20.11.1, my DNS server, and I'm going to select traffic type to be vMotion here and click on create. Now that I've defined both of the network profile types, I can go ahead and create my compute profile. Okay, click on the create compute profile button, enter a name for the compute profile, click continue, and then I have to select the services that I want to be activated as part of this compute profile. Now these services include, of course, the basic hybrid interconnect, which is required to create the service mesh, and then there are additional options such as WAN optimization, network extension, bulk migration, cross cloud vMotion migration, replication assisted vMotion, and of course disaster recovery as well. You can select which services you want and disable the other services. All of these features are included with the exception of SRM integration and OS assisted migration. You click continue. Here I'm going to select the resources where the services that I want to migrate with VMware Cloud and AWS are. In my case, they are in the same cluster, so I have selected the resource DC2 and resource cluster 2. I'll click on continue. Then I have to decide where I want to deploy my HCX interconnect appliances. I've already selected the resource cluster 2 and the vSAN data store that I want to deploy the appliances in, as well as the folder. So you have to be selecting here which folder you want to deploy the interconnect appliances in. If you want to select reservations to use for your interconnect appliance, you can do so. And there are some reservation recommendations available as best practices that you can follow for production environments. In my case, I'm not putting any reservations in place. I'll click continue. This is where I have to start selecting the network profiles that I had created earlier. So recall earlier that for management, I had defined the management DC2 network profile. So I'll select it for management. Click on next, and I can see the number of free IPs. So I'm going to click on continue here. For my uplink network, I'm also going to use the management network profile. So I'll select management for my uplink as well. Then I'll click continue. For my vMotion, if you recall, I had created a separate network profile, and I'll select vMotion. Notice that there is a suggested network that the HCX wizard suggests to use. Evaluate whether that is the correct one and use it as needed. I'll click and select vMotion and click continue. And finally, for my vSphere replication network, you can see that the management network is automatically selected. If in your environment you're using a separate VM kernel adapter for vSphere replication, think about using a separate network profile. Otherwise, the management network profile is used, and then click continue. Then I have to select the network container. The network container in this case is the virtual switches or the transport zones when in the case of NSXT that should be used for the compute profile. I have a single distributed virtual switch where my networks live that I may extend as part of the migration. So make sure to select the network containers that you may foresee using as part of your HCX network extension operations. And then click on continue. It's going to generate a set of connection rules, which are firewall rules that you should evaluate whether you need them or not and make sure that they're in place before you proceed. You can see here that I have WAN connection rules that I should make sure that my source IP addresses that I selected as part of my network profile can read the remote HCX appliances. Similarly, there are LAN connections between my vCenter server and my HCX appliance, and my ESX servers and my HCX appliance. All of these details are pulled in as you're building the compute profile and as you're selecting the services cluster and the deployment cluster. All of these details are generated based on that. Make sure you review it and put the required firewall rules in place before proceeding. Then click on continue. Okay, there are no errors and I can click finish. My compute profile is now created. However, the service mesh is still not deployed. I have to make sure that my VMware Cloud and AWS HCX Manager compute profiles and network profiles are also configured correctly. So if I come into my HCX Manager configuration that is deployed on VMware Cloud and AWS, I can see that the compute profiles and network profiles are pre-created automatically for me when I deployed HCX. I did not configure any of these and they're automatically configured. You can see that there are two network types that are network profile types that are available for me. There is the direct connect network profile and the external network profile. Note also that two public IP addresses are automatically allocated for me in the environment. If we go into the SDDC console, we can actually see that the public IPs are allocated automatically for HCX within the VMware Cloud and AWS console. So if I go to network and security, public IPs, I can see that the HCX Manager public IPs deployed, as well as the two public IPs for called HCX Fleet 1 and Fleet 2 that are used here for external network connectivity. So if you're using HCX or the public internet, you will use the external network profile for your uplink. However, if you're using direct connect, like in our case, then you should use the direct connect network profile. Please make sure that you edit the direct connect network profile and enter the IP addresses to be used. So I'll edit that and make sure I put in my IP address range that I want to use, 20.100.10 till 172.20.100.20. I'll put the subnet prefix and the gateway address. The DNS settings cannot be modified here because they're managed from the Cloud Console under the DNS settings. So we do not manage those here. This is again an optional setting that you can choose for HCX uplink or not. This is how suggestions will be provided when you're creating the compute profile. One thing to note here is that this network should be unique across your complete environment, because a subnet will be automatically created and advertised back to your on-premises environment over the direct connect link. So I'll click on update here, and this will go ahead and update my network profile. But at the same time, if I go into my direct connect configuration, I will see that right now there is no 172.20.100 network, but after I have created this profile and defined the IP pool, it will eventually start advertising this network back to on-premises so that we can establish the connectivity, and the management uplink that I selected in my on-premises network profile can reach this private IP address that is in the cloud. It does take a little bit of time for it to start refreshing. As you can see, it is now already advertising the IP back to on-premises. Next, remember the compute profile can be edited after it's created. So I'm actually going to go into the network settings and change the uplink network, which is by default set to the public IP external network profile, and change it to direct connect, and click close, and go through the remaining tabs by clicking continue and finish. And I can now proceed with creating the service mesh. Okay, now I'm in my on-premises ACX console. I'm going to create service mesh, select the sites. So I have these two sites only paired in my environment. I'll click continue. And then this is where I have to select the compute profiles that will become a part of my service mesh. Now we are at the point where we are defining this service mesh, and that is then going to go ahead and deploy the ACX interconnect appliance and the WAN optimization appliance, as well as the network extension appliances. So I select the compute profiles on both sides, click continue, select which services I want to activate, and here I have an override option to override which network profile I want to use. Now this is something I would have to do for the destination site, which is the VMware Cloud and AWS environment, if I was using the default compute profile, but I had already gone and changed my compute profile, so I don't need to worry about this. I can click continue. Make sure to select the number of network extension appliances that you want to deploy. I just want to deploy one network extension appliance in my case. I'll click continue. VMware has enabled ACX Enterprise features such as traffic engineering. So if you're looking to have application path resiliency or TCP flow conditioning enabled for your environment, you can select that here. You can also do bandwidth optimization and put limits so that your WAN link is not completely saturated when ACX is being used for migrations. Network extension is not using WAN optimization. That's one thing to keep in mind. I'll click continue. That is the topology overview. You can see how the ACX WAN appliance, the interconnect appliance, connects to the vMotion network as well as the management network. The WAN optimization appliance on premises only connects to the management network and directly to the interconnect appliance, and the ACX network extension appliance is also connecting to the management appliance for uplink, and the ACX manager is also connected to the management network profile. On the remote side, you can see that we have the direct connect network that is providing the uplink connectivity, and I have the network extension appliance, the ACX interconnect appliance, both using the direct connect network for uplink network connectivity back to the on-premises environment, and my management network, which is the default selected network, is being used by ACX manager and all three appliances. I'll click continue and put a friendly name for my interconnect appliances. So I'm going to say ACX-site1 and click finish. This is going to go ahead and start the service mesh appliance deployment process. Okay, after a few minutes, I can see that my ACX service mesh has been fully deployed and my services are all online. The interconnect service, the WAN optimization service, the network extension service, and all the other services that I selected at the time of creating my service mesh are online. If I go into my vCenter environment in VMware Cloud and AWS, I can see that I have three ACX appliances deployed here. And if I look in my on-premises vCenter server, I can also see that I have my WAN optimization, my interconnect appliance, and my network extension appliances all deployed. So now we are at the phase of going ahead and stretching on-premises networks to VMware Cloud and AWS. So for that, we'll go into the network extension tab here and click on create a network extension. Okay, so now I'm going to select the network that I want to stretch. That's going to be lab3-db in this case. Click next. Select the destination site first hop router, which is going to be the compute gateway within VMware Cloud and AWS. I can choose to enable mobility optimized networking, which is a feature that allows us to control how routing happens within VMware Cloud and AWS for virtual machines that are migrated to VMware Cloud and AWS. I will enter an IP address for the router. That's going to be 10.30, 10.3.30.1 and prefix address, and I'm going to click on submit. And that's going to start the process to extend that network to VMware Cloud and AWS. The process takes a little bit of time, but once done, we are ready to migrate workloads from our on-premises environment to VMware Cloud and AWS completely online and while keeping the same IP address for those virtual machines. After a few minutes, the extension is complete and we can now migrate a virtual machine. In order to do that, we're going to go into the Cloud Gateway console, which allows us to see both vCenters. I'm actually going to select one of the virtual machines here and migrate them. Before I start that, I want to highlight that I have a virtual machine here that is on the same network as the virtual machine I'll be migrating. And I will start a continuous ping from this IP 10339 to this IP 10338. So I am on the right virtual machine. I'm going to ping 10.3.30.8, and this ping will continue until the virtual machine finishes migrating. I'll right click on the virtual machine. Since HCX is fully integrated into the vCenter console, I can simply click on HCX action, migrate to target HCX site, and once it's loaded, it shows that it's migrating from HCX connector site 1 enterprise, which is the on-premises environment, to the vCenter cloud environment that you can see here. I have to select the compute container, the storage target for the migration, the folder where I want to place the virtual machine. I can choose to change the provisioning type, and I can also have an optional switchover schedule for my migrations. But since I'm going to be doing a vMotion based migration, it will be completely online. Let me say a name, so migration wave 1, for example, and I'm going to click validate. Validation is successful. That means I can go and start off my migration. I can monitor that progress in the HCX console that's integrated here into vCenter, or I can monitor it directly from the HCX console that I'm logged into. So I'm going to go into my migration tab, and I can see the wave that the migration wave and the migration group that I started, and I can see that the migration has been initiated. As time passes, I will be able to see the progress for this migration and the various events that are being processed under the events tab. Also, keep in mind that the current ping time that we're seeing here is well under 1 millisecond. Once the VM transitions to the cloud SDDC, we should see that latency go up, but there should be minimal to no packet loss as that transition happens. Here we can see that it's resolving the IX interconnect appliance, collecting the target details now, and we can actually monitor all the events as they happen. It will take a few minutes for the actual migration to complete. So you can see that the relocate task has actually been started. And if I expand this, I should see that the relocate virtual machine vMotion task has been started here. And so far, there has been no interruption to the traffic to the virtual machine. And we can see that both the on-premises vCenter and the Cloud vCenter vMotion tasks are visible in the Cloud Gateway appliance. And here in the destination side, we are actually seeing the virtual machine appear under that pseudo host that is created by HCX. And as the vMotion occurs, it's being done to that pseudo host, and then it will be completely put into the actual host that is being running inside VMware Cloud and AWS. We can see that the migration is 47% complete from a base sync perspective. So far, here we see that there was a mild drop in traffic. About 3 packets were dropped, but the traffic, once the virtual machine traffic switched to the other side, it continued seamlessly. We can actually see the virtual machine is now fully operational in the destination side, and it's appearing for a few seconds here under that pseudo host before it is completely removed and the vMotion transaction is fully complete. I can actually click on the virtual machine here, launch a web and this is now showing me the console for the virtual machine in the destination side. Now my virtual machine is running in VMware Cloud and AWS, and the vMotion is complete. This will disappear. So we saw how we put together the whole HCX environment end to end to conduct the migration from our on-premises environment to VMware Cloud and AWS. The final part of the demo that we're going to look at today is the mobility optimized networking feature I talked about earlier. It is an included enterprise feature of the HCX network extension service that allows us to control how VMs in the SDDC that are running on an extended network communicate with the other routed segments in the SDDC, the internet, and even the S3 buckets. Now, this is the virtual machines that we are migrating from our on-premises environment to VMware Cloud and AWS. In our demo environment currently, the ping latency between a VM in the SDDC and in the on-premises environment on the same L2 network is approximately 2.1 millisecond on average. So I'm going to show the latency here between this virtual machine, which is 10.330.8, to this virtual machine, which is 10.330.9. So going into our demo environment, I have the SSH sessions open to my virtual machines. You can see that on my on-site environment, I have this VM 10.330.9, and in the cloud, I have this migrated VM that we just migrated with 10.330.8. So from my on-premises virtual machine, I'm going to start a ping to the virtual machine that we just migrated to the cloud, which is 10.330.8. And we can see that the ping is around 2.1 millisecond on average. Now, the other thing is, what about when we try to communicate with this virtual machine that is also in the SDDC, but on a different segment? Keep in mind that mobility optimized networking is currently disabled for this virtual machine. We can see here that that latency goes up to 3.4 milliseconds. So let me show that here. I'm going to run a ping from the 10.330.8, which is the virtual machine that we just migrated to the cloud, and then another virtual machine, which is 10.7.107.2, which is running in the SDDC on a segment of the SDDC. So 10.7.107.2. And we can see that that ping is roughly 3.4 milliseconds, and at times fluctuating even higher up to 5 milliseconds. This is because traffic from this virtual machine going to this virtual machine actually has to go all the way back to the on-premises over the L2 network extension, go to the customer on-premises router, and then head back over the L3 connection or direct connect connection that we have into the compute gateway and then the virtual machine. This is what really adds to our latency when we're talking about communication between these two virtual machines. Now, what happens when we activate mobility optimized networking for this virtual machine? VMware HCX network extension service intelligently directs traffic that is destined to this virtual machine through the compute gateway, greatly reducing the latency between these two virtual machines. Let's see how we can enable that. So I'm going to go into my HCX console, and under network extension, I'm going to look at the virtual machine, which is 10.3.30.8 that we just migrated. Remember earlier we had already enabled mobility optimized networking for this network extension at the time of deployment. I'm going to change the target router to the HCX Cloud instead of the extended network and click on submit. Let's see what that does to the ping latency from our migrated virtual machine to the virtual machine running on a routed segment within the SDDC. Here we can see that the ping between the migrated virtual machine and the virtual machine that is running on premises on the same L2 segment remains at around 2.1 millisecond. But here we can see that the ping from the virtual machine that we just migrated and the virtual machine on a connected subnet immediately drops to under 1 millisecond. So here is what that means. Any traffic that is destined from this virtual machine to the other virtual machines that are on the same compute gateway routed segments is immediately directed over this compute gateway. And all virtual machine traffic that is destined for on-premises networks still goes over the layer 2 extension, thereby reaching the on-premises virtual machines and all other on-premises networks via the on-premises router. So we can see that this ping is staying at 2.1 milliseconds, and this has now come down to 0.3 milliseconds on average. So how does mobility optimized networking do this? It uses a feature called policy routing. Policy routing is actually visible within the advanced section. So you can see the policy routes for this network extension. And here we can see once this loads, there are the default RFC 1918 routes are always sent back to the source with HCX. So this is a default setting that is included. That means that all customer private IPs that are trying to be reached from this extended segment will always be sent over HCX back to the on-premises environment. If the traffic is intended to a segment that is connected to the VMware Cloud and AWS compute gateway, that traffic is directed over the compute gateway directly to the virtual machine instead of going over the HCX connection.
And with that, thank you very much for attending this session. If there are any questions, I'm happy to answer them. But I would like to thank you for attending, and I also like to thank my chat moderators, Harsha Sanku and Dave Davis, for helping out with this session today.